Hey guys, so this is the beginning of Limit.4. This is actually the start of derivatives. So this is where the limits run into derivatives. So we're going to learn how to do a derivative by using limits. And then our next unit, which will be our last unit, will be all about derivatives. Now, I am hoping at this point, if you haven't already, you stop this video and watch the Khan Academy one explaining why we have this really weird looking formula here. He'll hopefully explain to you how it relates to just slope formula. So this right here is really just slope formula. Derivative is all about trying to find the slope at a single point. Okay, so derivatives may seem a little weird right now. After next chapter, hopefully they'll make a lot more sense. And if you watch that video, hopefully they'll make a lot more sense. All right, than otherwise if you didn't. So in this video, I'm just going to explain how to do two problems because there's really only two types of problems in here. I have a linear problem, so number 1, and then I have some quadratic, so I put number 7 because it has two variables in it. So a linear and a quadratic, really the only two types of problems we have on this. The rest all fall into one of those categories. So let's get started. Okay, so I'm going to start with number 1. Here is the formula I use. I use this little triangle X, which stands for delta X. If you were took physics, you would have learned about delta being the change in, so the change in X. So this is the change in X approaching 0, meaning my 2 points are getting so close together that the difference between them is approaching 0, which is why we have some trouble with our slope formula. All right. So we're using this formula. We're just going to plug in. It says f of x plus delta x minus f of x over delta x. Okay. And clearly, if I just plug into delta x in now, I get f of x minus f of x over 0, which gives me 0 over 0, which is why we need a real equation and do a little math to figure it out. Okay. All right. So I'm going to plug this into this formula. So I'm going to write the limit of delta x approaches 0, and then my f of x. And so for this right here, I'm just saying x plus delta x is being plugged in here. So x plus delta x, plug in there. Okay, so my f of x plus delta x is just negative 5 x plus delta x minus 2. Okay, so that is my f of x plus delta x. I just plug that into my function, into the variable. Okay, and then minus f of x. Well, f of x is just a function like they give it to me, negative 5x minus 2, all over delta x. Okay, now if you can figure out how to get that far, the rest is actually pretty easy. A little tedious maybe, but it's some very basic algebra. If you can just put it in that form right there, the rest should be pretty simple. So let's just do some basic algebra. I'm going to distribute that negative 5, and then I'm going to distribute that negative. So if I start off distributing my negative 5, limit as delta x approaches 0, I get negative 5x minus 5 delta x. I always have to put my delta x in parentheses. Minus 2, if I distribute that negative, gives me plus 5x plus 2 all over delta x. Okay. All right, next I'm going to combine like terms, which should end up with everything that doesn't have a delta x in it canceling out. So notice I have negative 5x and positive 5x. They cancel out. I have negative 2 and positive 2. They cancel out, leaving me with negative 5 delta x over delta x. Well, now at this point, I'm looking at this like, oh, now my delta x's cancel out. And I'm left with -5. Well, there is no delta x to plug 0 into, so when I had the limit of a constant, the answer is just -5. Okay. Now, let's try this, but let's try it with this one right here. So here's my problem. I'm going to bring it down. So I'm plugging x plus delta x into both of my x's. Okay. So I'm going to say the limit as delta x approaches 0 of 5x plus delta x squared plus 3x plus delta x plus 5. So there's my f of x plus delta x part. Again, just plugging in that. And then it's minus f of x. So I need to now subtract my function. 5x squared plus 3x plus 5 all over delta x. Okay. All right. Takes up width of my page there. I need to figure some things out. Right away, I see this right here, x plus delta x squared. I'm going to figure that out here off to the side. X plus delta x squared means I'm multiplying it by itself. And then maybe if we use the box a good bit, maybe that's a good way of doing that. X plus delta x, x plus delta x. If I multiply, it gives me x squared. This is going to give me delta x times x, delta x times x, and this is going to give me delta x squared. Okay. Now, delta x times x is not like delta and then x squared. I cannot combine those. They're two different things. Even though that has two symbols on it, it's really one variable. So that's why I put in parentheses. I'm just going to leave it like that. Okay. So now I'm going to rewrite this. I'm going to substitute that in here and then hopefully simplify the rest as I go down the line a little bit. All right, so that all became, oh, and I didn't simplify this one, sorry. I can combine those two terms, so this becomes x squared. Well, there's two of them, so that becomes 2 delta x, x plus delta x squared, okay? So that's what I'm going to put here, x squared plus 2 delta x times x plus delta x squared. Okay, I'm going to distribute this one and say that's plus 3x plus 3 delta x plus 5. Go ahead and distribute that negative sign and I'll get minus 5x squared minus 3x minus 5. All right. Oh, and of course, all over delta x. All right, now we need to distribute our 5. That becomes 5x squared plus 2. Sorry, no, not 2. 5 times 2 is 10 plus 10 delta x, x, 5 times, so plus 5 delta x squared plus 3x plus 3 delta x plus 5 minus 5x squared minus 3x minus 5. All right, yes, realize that's not even staying. Oh, I think maybe it's barely fitting on my screen, cutting a little bit of my limit off. All right, there we go. Now we can start to really simplify this and make this hopefully make some more sense. Let's see what cancels out. Here's a positive 5 and a negative 5. Remember, everything that doesn't have a delta x should cancel out. Here's a positive 3x, negative 3x. Here's a positive 5x squared, negative 5x squared. And sometimes other things with delta x's will combine. That's not the case here, and that's okay. All right. So let's write it out now that I've canceled stuff out. All right, so I got 10 delta x plus 5 delta x squared plus 3 delta x all over delta x. All right, there we go. A lot less terms we have to deal with now. A couple of different ways we can do this next step, but to make the most sense, I'm going to factor out a delta x, just one delta x, out of the numerator. So limit of delta x approaches 0. So if I factor out a delta x, what am I left with? Well, this right here means I'm factoring that delta x out. I'd be left with 10x plus, factor out one of those, I'm still left with a 5 delta x. Factor that out, and I'm left with plus 3 over delta x. The reason I do that is because now I can say, oh, delta x, those two cancel out. Now, you're smart. You could have figured out how to cancel a delta x out of each of those without canceling both of those out, hopefully, and gotten this either way. But by factoring it out, I found that helps students really see that as easily as possible. All right, so I factor that out. What do I have left? Still have my limit, delta x plus 0 of no longer a fraction because I cancel the bottom out, so the bottom's just 1 now. 5 delta x plus 3. Notice I still have a delta x in there. All right, so I still have my limit here. Well, at this point, I want to actually plug in. So just like when we did limits, we wanted to plug that number in if possible. Oh, well, now I'm going to take that number and plug it in for delta x, giving me 10x plus 5 times 0 plus 3. Well, 5 times 0 is 0. And 0 plus 3 is 10x plus 3. That is my derivative. And yes, I realize there is an x in there. Whenever you take the derivative of a quadratic, your answer is going to be a linear function. So you're going to have an x in there, and that's okay. Now, I don't know if they talked about this because I didn't talk about this in the last one, but the proper notation is going to be f apostrophe x. All right, f prime of x, that's my derivative. I should have put this up here as well. F prime of x to show that that is my derivative. All right, hopefully that made sense to you, but if not, again, send me a message. I'll be glad to meet with you on Zoom one-on-one to help you